This phenomenon has been observed throughout history, with some of the most notable examples being the 1815 eruption of Mount Tambora, which caused the year without a summer, and the 535 AD eruption of Krakatoa, which led to a global cooling event. The potential consequences of volcanic winter are catastrophic, and it's essential to understand the risks and prepare for such an event. Associate Professor Martin Danisic from Curtin University explains,
Super eruptions are among the most catastrophic events in Earth's history, venting tremendous amounts of magma almost instantaneously. They can impact global climate to the point of tipping the Earth into a volcanic winter, which is an abnormally cold period that may result in widespread famine and population disruption.
In recent years, we've seen an increase in volcanic activity, with many scientists warning that a major eruption could be on the horizon. With the rising threat of climate change, it's crucial to explore the implications of volcanic winter and its potential to exacerbate the problem. The history of volcanic winter is filled with stories of devastating consequences, from crop failures to widespread famine. In the 18th century, the Laki eruption in Iceland caused widespread poisoning as toxic gases and heavy metals contaminated the air and water supply. The potential for a similar disaster is still present today. The eruption of Mount Tambora in 1815 is a prime example of the devastating power of volcanic winter. The massive explosion caused widespread crop failures, leading to famine and disease outbreaks across the globe. The event even inspired Mary Shelley to write her classic novel, Frankenstein, as the cold and gloomy weather forced her to stay indoors for extended periods. Regarding the possibility of another Mount Tambora, Markus Stoffel, a climate expert, warns,
Scientists now warn that another catastrophic volcanic eruption could occur, mirroring the deadliest disasters in history. In 1815, Mount Tambora in Indonesia unleashed the largest recorded volcanic eruption, blanketing the sky with ash and sulfur dioxide. This led to a dramatic drop in global temperatures, triggering what became known as the year without a summer. Crops failed, famine spread, and tens of thousands died. Snow fell in June in parts of North America, and Europe experienced widespread food shortages. Unlike past centuries, today's interconnected world faces amplified risks from volcanic disasters. A Tambora-scale eruption could devastate cities near volcanoes, disrupt global food supplies, and destabilize economies.
Moving on to the science behind volcanic eruptions and climate change, let's explore the mechanisms that lead to this phenomenon. When a volcano erupts, it releases massive amounts of ash, sulfur dioxide, and other gases into the atmosphere. These particles can reflect sunlight, cooling the planet, and also react with atmospheric water to form acid rain. And according to Zachary McGraw, a postdoctoral researcher at NASA's Goddard Institute for Space Studies,
the relatively modest temperature changes we found most compatible with the evidence could explain why no single super eruption has produced firm evidence of global-scale catastrophe for humans or ecosystems.
Zachary McGraw's research at NASA's Goddard Institute for Space Studies focuses on understanding the climatic impacts of volcanic aerosols. His studies suggest that while super eruptions can inject significant amounts of aerosols into the atmosphere, the resulting temperature changes might not be as catastrophic as previously thought. He emphasizes that the cooling effect depends on various factors, including the size of the aerosol particles. The 1980 eruption of Mount St. Helens is a prime example of the impact of volcanic ash on the environment. The massive plume of ash that rose into the atmosphere blocked out sunlight, affecting the local climate and causing widespread damage to crops and infrastructure. Dr. Steve Quayle, a volcanologist at the United States Geological Survey, USGS, elaborates.
The 1980 eruption of Mount St. Helens was a landmark event in the study of volcanic ash and its environmental impacts. When the volcano erupted, it released an enormous ash cloud that traveled across the United States. The ash contained fine particles of glass and rock, which posed significant challenges for air quality, contaminating water supplies and damaging both natural and human-made environments. In the agricultural sector, the ashfall caused severe damage to crops, with some fields rendered unusable for years. The fine particles also clogged machinery and disrupted transportation networks, leading to economic losses. The eruption caused the loss of wildlife habitats and forced animals to migrate or perish. Long-term environmental changes included alterations to the landscape and ecosystem dynamics. The areas affected by ashfall underwent significant ecological succession, with new plant and animal communities gradually establishing themselves. This event underscored the importance of monitoring volcanic activity and preparing for potential ashfall impacts, particularly in regions near active volcanoes.
In addition to acid rain and ashfall, volcanic eruptions can also release large amounts of sulfur dioxide into the atmosphere. This gas reacts with water and oxygen to form sulfuric acid, which can lead to the formation of aerosols that reflect sunlight and cool the planet. The 1991 eruption of Mount Pinatubo is a classic example of the impact of sulfur dioxide on the climate. The massive release of this gas into the atmosphere cooled the planet by about 1/2 degrees Celsius, affecting global temperatures and weather patterns.
Check one, check two, check.
Michael Rampino, a professor of Earth and Environmental Sciences at New York University, discusses the long-term effects of sulfur dioxide release on the climate.
Volcanic eruptions that release large amounts of sulfur dioxide into the atmosphere can have significant long-term effects on the environment. When sulfur dioxide is injected into the stratosphere, it reacts with water vapor to form sulfuric acid aerosols. These aerosols can remain in the stratosphere for several years, reflecting sunlight away from the Earth and causing a cooling effect known as volcanic winter. The cooling effect can lead to lower global temperatures, which in turn can reduce agricultural productivity and disrupt ecosystems. For example, the drop in temperatures can lead to shorter growing seasons and lower crop yields, potentially causing food shortages. Additionally, the cooling effect can impact weather patterns, leading to changes in precipitation and other climate variables. Furthermore, sulfuric acid aerosols can contribute to the depletion of the ozone layer. The ozone layer is crucial for protecting life on Earth from harmful ultraviolet radiation. When the ozone layer is depleted, it can result in increased ultraviolet radiation reaching the Earth's surface, which can have harmful effects on both the environment and human health. The long-term impacts of volcanic sulfur dioxide emissions highlight the importance of monitoring volcanic activity and understanding the potential consequences of large eruptions. By studying past events and improving our predictive models, we can better prepare for and mitigate the effects of future eruptions. Climate models have shown that the injection of large amounts of sulfur dioxide into the atmosphere can lead to a decline in global temperatures, as well as changes in precipitation patterns. This in turn can affect agricultural productivity, leading to food shortages and economic instability.
Imagine a scenario where a massive eruption occurs today, releasing enormous amounts of ash and sulfur dioxide into the atmosphere. The initial blast would be devastating, with widespread destruction and loss of life. As the ash cloud spreads across the globe, it would block out sunlight, affecting global temperatures and leading to crop failures. The environmental consequences would be catastrophic, with acid rain and heavy metal contamination affecting ecosystems and wildlife. The impact on human health would also be severe, with respiratory problems and other diseases on the rise. In the aftermath of the eruption, the global economy would likely collapse, as trade and commerce grind to a halt. The lack of sunlight would lead to a decline in agricultural productivity, resulting in food shortages and widespread famine. As the world struggles to recover from the initial disaster, the long-term effects of volcanic winter would begin to manifest. The decline in global temperatures would lead to a shift in climate zones, resulting in the expansion of polar ice caps and a decline in sea levels. Ecological shifts would occur as species adapted to the new climate, leading to a loss of biodiversity and ecosystem disruption. The impact on human societies would be immense as communities struggled to adapt to the new environment. Dr. Sierra Vasquez, a researcher specializing in volcanic impacts on biodiversity, elaborates on the effect on biodiversity and ecosystem disruption.
Massive volcanic eruptions can profoundly disrupt ecosystems and lead to a significant loss of biodiversity. The immediate aftermath of an eruption often involves the destruction of habitats through lava flows, pyroclastic flows, and ashfall. This sudden and drastic change can lead to the death of many plant and animal species that are unable to escape or adapt to the new conditions. For example, the 1980 eruption of Mount St. Helens led to the destruction of vast tracts of forest and the loss of numerous species. However, volcanic eruptions also create new landscapes and habitats. Over time, these areas can become sites of ecological succession, where new plant and animal communities establish themselves. The recovery process can take decades or even centuries, but it often results in the development of diverse and resilient ecosystems.
The eruption of Mount St. Helens has provided valuable insights into the processes of natural regeneration and ecological recovery. Studies of the area have shown how pioneer species, such as certain types of grasses and shrubs, are among the first to colonize the barren land. These species create conditions that allow other plants and animals to move in, leading to a gradual increase in biodiversity.
In the long term, volcanic eruptions can contribute to the formation of rich and unique ecosystems. The nutrient-rich volcanic soils support diverse plant communities, which in turn support a wide range of animal species. While the initial impact of a volcanic eruption on biodiversity can be devastating, the subsequent recovery can showcase the resilience and adaptability of nature.
The potential consequences of volcanic winter are dire, and it's essential that we take steps to prepare for such an event. By understanding the science behind volcanic eruptions and climate change, we can develop strategies to mitigate the effects of a massive eruption. It's essential that we take steps to prepare for such an event by investing in climate modeling, geological monitoring, and disaster preparedness. By understanding the risks and consequences of volcanic winter, we can work towards a safer and more sustainable future. So what do you think about the concept of volcanic winter? Share your thoughts in the comments below, and if you're interested in learning more about natural disasters, be sure to check out our other videos on the topic.